AI, it's like, it's everywhere these days.
Yeah,
You're
you
doing
think?
all sorts of things, like just everyday stuff to like some really big, ambitious things.
Yeah, yeah.
And one of the things that's driving that is that a lot of these really powerful AI models are openly available. So
Mm,
you've got all these people building all sorts of cool things with them.
absolutely, yeah. And the easier it is to get your hands on these foundational models, the more people can experiment, right?
Right.
And the faster we can sort of collectively figure out what AI can actually do,
Yeah.
it makes for a way more vibrant and collaborative environment
Yeah.
for everyone, really.
Yeah. Yeah. Makes a lot of sense. And that kind of brings us to what we're going to be looking at today.
Okay.
The brand new Llama 4 family of AI models.
Right.
We got kind of an early peek at these
Okay.
thanks to a blog post that came out just yesterday, April 5th, 2025.
Right.
It's called The Llama 4 Herd, the beginning of a new era of natively multimodal AI innovation.
So what we're going to be doing today is kind of our goal is to break down what do these models mean for you?
Yeah.
What are the core advancements they're bringing to the table? And how might these advancements kind of change how AI develops
Mm.
and what we can actually do with it in the future?
Right. And one of the things, like right off the bat, it's this idea of like more personalized experiences that use like multiple kinds of information.
Hmm.
It sounds like these models are built to understand and interact with the world in a much, much richer way.
Yeah,
More like how we do, right? By processing not just text, but images and even video.
yeah, for sure. I think that's definitely the direction that the field's moving in. For AI to be truly intelligent and
Mm.
truly helpful,
Yeah.
it needs to be able to understand information coming in lots of different forms,
Hmm.
like seamlessly, right? So
Yeah.
text, images, sounds,
Right. It can't just be one thing.
can't just be one thing.
So the post introduces us to three main models:
Okay,
Llama 4 Scout,
okay.
Llama 4 Maverick, and then a sneak peek at something called Llama 4 Behemoth.
All right. I like the names.
Yeah, right.
So
Mm.
uh, maybe we start with Llama 4 Scout.
Yeah, let's jump into Llama 4 Scout.
Okay. So Llama 4 Scout, they're calling it the best multimodal model in its class,
Okay.
which is a pretty bold claim right out the gate.
Right.
But let's look at the specs. 17 billion active parameters.
Okay.
Uses 16 different expert components internally. And what's really interesting is that it's designed to run on a single NVIDIA H100 GPU.
Wow. Okay.
Particularly if you use what's called in-4 quantization. That's basically a way of making the model's calculations more compact, but without losing too much accuracy.
Okay, so that accessibility is a big deal.
Absolutely.
Right. But it's not JSD about fitting on the hardware. It's about like the performance you get.
Yeah, yeah, for sure.
They're saying that this thing is more powerful than all the previous Llama models. It even beats out some of the big names like Gemma 3, Gemini 2.0 Flashlight, and Mistral 3.1 across a whole bunch of different tests.
Yeah,
That sounds like a pretty significant jump forward.
yeah, for sure. For sure. And one of the things about Llama 4 Scout that really stood out to me was it's got this industry-leading 10 million token context window.
Okay, break that down. 10 million tokens, like what does that actually mean? What can you do with that?
Okay, so think about summarizing multiple, very long documents on a scale we haven't really seen before.
Okay.
Like, you could feed this model all the existing research on a certain scientific discovery,
Mm-hmm.
and it could give you a very comprehensive, nuanced overview. You could even, like, create personalized tasks based on a very, very deep understanding of everything a user has done in the past.
Wow.
And for developers, right, who need to understand and work with huge amounts of code, this opens up all sorts of possibilities for finding bugs, for generating new code, for understanding complex software systems. It's really quite amazing.
So how does it handle that much information? They mentioned something called the IRO-E architecture.
Right.
Interleaved attention layers without positional embeddings and inference time temperature scaling of attention. That sounds pretty technical. What's the core idea there?
The idea is to push the limits of how much context a model can actually handle,
Okay.
potentially even going towards what they're calling infinite context.
Wow.
So by interleaving the attention layers in a specific way and getting rid of fixed markers for where words appear in a sequence,
Okay.
the model is much more adaptable to processing sequences of different lengths.
Right.
And that inference time temperature scaling is another technique that helps the model generalize to much longer contexts. Pretty innovative.
Okay, so it's not just about text though, right? It's multimodal. It can take in images, it can take in video.
Yeah, exactly. Llama 4 Scout is designed to understand multiple types of information right from the start. So it's pre-trained and post-trained with a 256,000 token context window that's specifically for handling both text and visual information.
Okay.
And they trained it on a huge variety of images and still frames from videos. So this gives it a very broad understanding of what things look like.
Yeah.
It can even understand actions that happen over time and how different images relate to each other. And in the later stages of training, they actually tested it with up to 8 images at the same time.
So it can look at like a series of pictures and kind of grasp what's going on.
Exactly, yeah. And a key strength they're highlighting is what they call best-in-class image grounding. So what that means is it can really understand the connection between a text prompt you give it and what's actually in an image.
Okay.
It can link words to very specific parts of an image and use that to give more accurate answers to questions about the image.
So that's really a game changer if you're working with visual data.
Absolutely.
So for anyone who wants to try it out, Llama 4 Scout is available to download right now on llama.com and Hugging Face,
That's great.
which shows, a commitment to making this stuff openly accessible.
Yeah, that's awesome.
So what about Llama 4 Maverick?
All right, so Llama 4 Maverick, this one is also described as the best multimodal model in its class, but with a particular emphasis on getting great performance for the computing resources that it uses. So like the best performance per compute cost.
Okay, so how does it do that?
Well, let's look at the specs. 17 billion active parameters, same as Scout,
Okay.
but a much larger number of internal expert components, 128 to be exact. So the total number of parameters in the model is a pretty massive 400 billion, but it's designed to run on a single H100 host. So this really demonstrates how efficient this mixture of experts architecture can be. Basically, the model have lots of different specialized modules.
Yeah.
And only a small subset of them are actually activated for any given task.
Okay. Interesting. And how does it perform?
Well, according to the blog post, it outperforms both GPT-4o and Gemini 2.0 Flash across lots of different benchmarks. What's really interesting is that it achieves results comparable to the very recent DeepSeek V3, which is very powerful
Yeah.
on things like reasoning and coding tasks, but does so with less than half the number of actively used parameters.
Wow.
That's a big gain in efficiency.
It's beating some models that are considered state-of-the-art, but using less
Exact
active parameters. That suggests some clever design choices.
Yeah, absolutely, yeah. And they even mentioned that an experimental chat version of Llama 4 Maverick achieved an ELO score of 1417 on the El Marina.
So for those who might not know, what is El Marina?
Oh, yeah, sure.
Sure.
El Marina is this popular platform where people compare the conversational abilities of different language models.
Okay.
And that score means that it's a very capable model for having natural-sounding conversations.
Okay, cool. So let's talk about the training.
Okay.
They used lightweight supervised fine-tuning, followed by multimodal online reinforcement learning, and then a lightweight direct preference optimization. What were some of the key things that they discovered in that process?
So one of the key things they found was that traditional methods of fine-tuning and preference optimization can sometimes limit the model's ability to really learn and explore during the reinforcement learning stage. So to address this, they did something interesting. They used other Llama models to actually judge how difficult different prompts were.
Okay.
And then they removed over 50% of the easier prompts and focused the initial fine-tuning on the remaining harder ones.
Okay, so they kind of trained it more intensely on the trickier stuff.
Yeah, exactly.
Yeah.
Exactly. And then during the reinforcement learning phase, they continue to really focus on those harder prompts. They actually had this continuous online strategy
Okay.
where the model was constantly being trained and then being used to filter and keep only the prompts that were of medium to high difficulty. So this continuous feedback loop was really beneficial, not only for saving computational resources,
Yeah.
but also for improving accuracy. And then finally, they use the lightweight direct preference optimization to sort of fine-tune the model for response quality
Okay.
and to handle any remaining unusual cases.
So a really sophisticated way of training.
Absolutely.
So multimodality, how does Maverick handle, understanding both images and text?
Right. So they really emphasize that it offers industry-leading performance in understanding both images and text. And it's important to note that it can handle multiple input modalities without actually sacrificing performance in any individual modality.
Okay.
So it's not like it's good at text but bad at images, or the other way around. It's got this truly integrated multimodal intelligence.
Okay. And what are some of the use cases they're imagining for Maverick?
Well, they see it as kind of their main workhorse model for products.
Okay.
So things like General Assistant and chat applications,
Mhm.
tasks that require really precise image understanding
Yeah.
and even creative writing. Its strong all-around capabilities make it a very versatile tool.
And just like Scout, Maverick is also available for download on llama.com and Hugging Face.
Yep.
So again, that open access thing is a big theme.
Definitely, it is. Which I think really speaks to their belief in the power of the community to actually drive innovation.
Yeah. So let's move on to the model that's still in preview,
Okay.
Llama 4 Behemoth. The name itself kind of suggests something pretty big.
It does, doesn't it?
So what can you tell us about it?
Well, they're positioning it as Meta's most powerful large language model to date,
Wow.
and among the most intelligent in the world.
Okay.
It's huge EE,
Yeah.
288 billion active parameters,
Wow.
uses 16 expert components internally, and it has nearly 2 trillion total parameters.
2 trillion. So that's a whole other scale compared to even Maverick in terms of total parameters.
Sure, yeah.
How does it perform?
Well, they're saying that it outperforms GPT 4.5, Claude Sonnet 3.7, and Gemini 2.0 Pro
Wow.
on a number of demanding STEM benchmarks, specifically Math 500 and GPQA Diamond.
Okay, so what are those specifically?
So those are tests that assess mathematical reasoning and the ability to answer very complex questions across a wide range of scientific topics.
Okay.
So it's not just about being big. It actually translates to superior performance on really complex tasks.
Right. So what's Behemoth's role in the whole Llama 4 ecosystem?
So it actually serves as what they call a teacher model for both Llama 4 Scout and Llama 4 Maverick.
Okay.
So they use this process called co-distillation,
Okay.
where the smaller models essentially learn from the knowledge and abilities of this larger teacher model.
Okay.
So you can think of it as the big, smart model transferring its knowledge to the smaller ones,
Yeah.
which leads to big improvements in the quality of those smaller models.
That's pretty clever.
Yeah.
So they can create more efficient and deployable models like Scout and Maverick, but still benefit from the massive power of Behemoth during training.
Exactly.
So training a model that big must have been quite the undertaking.
Yeah, absolutely. During the initial training phase, they achieved a pretty remarkable 390 TFLOPs per GPU,
Okay.
using a type of numerical precision called FP8.
Yeah.
And they did this across a massive 32,000 GPUs. The amount of data they used was also huge,
Yeah.
over 30 trillion tokens.
Wow. 30 trillion tokens.
Which is more than double what they used for Llama 3. And the later stages of training at this scale required them to completely rethink how they were doing things.
Yeah.
So they pruned a whopping 95% of their supervised fine-tuning data,
Wow.
just to stay really focused and efficient. They also discovered that doing large-scale reinforcement learning, but really focusing it on those hard prompts,
Okay.
led to significant improvements in the model's reasoning and coding abilities. And they actually redesigned their entire reinforcement learning infrastructure,
Yeah.
which resulted in a 10-fold increase in training efficiency
Wow.
compared to previous generations.
Yeah.
So there was a lot of engineering and optimization that went into this.
So Behemoth is still being trained.
It is. It is.
So they're going to share more details later.
Yeah, they're still actively working on it. They're going to share more details later, including at their upcoming LlamaCon event on April 29th. So while we don't have the full picture just yet, it's very exciting.
So we've covered the three main models. Let's kind of step back a little bit and talk about some of the fundamental architectural and training innovations
Okay.
that make this family work.
Yeah, right.
So a key innovation that's used in all of the Llama 4 models is what they call the mixture of experts architecture, or MOE.
Right.
So can you kind of explain that?
Yeah, so basically, in an MOE model, only a portion of the total parameters are actively used for any given input.
Okay.
So you can think of it as like having a team of specialists inside the model,
Okay.
and only the relevant experts are actually consulted for each specific part of the task.
Yeah.
And this leads to much greater computational efficiency.
Right.
So both during training and when you're actually using the model.
So it's like having a big team and only the people with the right expertise are jumping in to help.
Yeah, exactly. Exactly. So for example, Llama 4 Maverick, even though it has 400 billion total parameters, only about 17 billion of those are actually activated when it's, generating a response, which really helps to keep costs and response times down.
Yeah, so you're only using what you need. Why use everything?
Exactly, yeah.
So multimodality isn't just an afterthought. It's like built in
It is.
from the ground up.
Yeah, they call it native multimodality with early fusion.
Okay, what does that mean?
So what that means is that the text and visual information are actually combined and processed together right from the very beginning
Okay,
within the model.
okay.
So this allows them to do joint training on massive amounts of unlabeled text, image, and video data, which leads to a much deeper and more integrated understanding across those different types of information. They've also improved their vision processing component. It's based on something called meta-CLIP,
Okay.
but they trained it separately alongside a frozen llama model, just to kind of better adapt it to the language model's capabilities.
Okay, so they're kind of fine-tuning the visual part specifically for this.
Exactly, yeah.
They mentioned something called Meta-P.
Right, so Meta-P is this new training technique they developed
Okay.
that allows them to reliably set these crucial training hyperparameters,
Yeah.
like, how quickly the model learns,
Yeah.
how it initializes its internal weights.
Okay.
And they found that these settings actually work well across different model sizes,
Yeah.
different amounts of training data, and different batch sizes.
Yeah.
So that makes it much easier to scale up and efficiently train new models.
And they made an effort to improve how it works with different languages as well, right?
He did, yeah.
Beyond English.
Yeah, for sure. Llama 4 was trained on text from 200 different languages,
Yeah.
including over 100 languages that had more than 1 billion tokens of training data each.
Wow.
So overall, they used 10 times more multilingual data compared to Llama 3. So this should significantly improve the model's ability to understand and generate text in a much wider variety of languages.
Right. And we talked about the incredibly long context window, 10 million tokens
Yeah.
of Llama 4 Scout. And they mentioned using specialized data sets during what they call mid-training to achieve that. So can you kind of explain what that is and why it's important?
Yeah, so extending the context window
Yeah.
that much, to 10 million tokens
Yeah.
requires specific kinds of training data
Okay.
and techniques to make sure the model can really effectively use and learn from those very long sequences of information
Yeah.
without getting confused or becoming less efficient. So these specialized data sets likely contained very long documents and conversations that were specifically designed to really test and push the limits
Yeah.
of the model's ability to kind of pay attention over those really long stretches of information.
Okay. So with all this power, it kind of brings up the question of safety
Absolutely.
and, developing these things responsibly. They
Yeah.
spent a good portion of the blog post talking about that.
It did, yeah.
So what are the key takeaways there?
Their approach seems to be about building safety at every stage of development.
Okay.
From the very beginning, preparing the data,
Yeah.
all the way to providing tools that developers can use to make sure their applications are safe.
So let's kind of break that down. What are they doing for safety in that initial data training and then the later, fine-tuning?
Okay, so in the initial pre-training phase, they're using all sorts of data filtering techniques and other methods
Yeah.
to try and remove harmful or biased content from the massive amounts of text and images they use to train these models.
Okay.
And then in the post-training phase, they apply various techniques, including incorporating specific safety-focused data
Yeah.
at each step of the process,
Yeah.
just to make sure that the models are behaving responsibly and following those safety guidelines.
And at the level of the software itself, they've got some interesting open source tools that they've released, right?
Yeah, they've actually developed and made available several different safety tools that developers can use
Okay.
that they can just easily integrate into their applications that are built with Llama models. So one of those is called Llama Guard,
Okay.
which is an AI model that's specifically designed to look at both the inputs and outputs of other AI models
Okay.
and determine if they might be harmful or violate certain safety policies.
So it's like a safety layer?
Yeah, it's a customizable safety layer for anyone who's building applications with Llama.
Okay.
They've also released Prompt Guard, which is a classifier model that's specifically trained to identify prompts that might be trying to trick the AI
Okay.
into doing something harmful
Yeah.
or bypassing its safety features. And then finally, they have CyberSecEval, which is this whole set of tests and evaluations designed to help developers understand and reduce the cybersecurity risks associated with using generative AI models.
Yeah. So they're really putting a lot of thought into not just building these powerful models, but making sure that they're used safely.
For sure, yeah.
And it sounds like they're taking a very kind of multi-pronged approach to testing and reducing risks, including something called red teaming.
Right.
So can you explain what that is?
Yeah, so they do systematic testing across a wide range of different situations and potential use cases for the models. They also use this thing called adversarial dynamic probing, which basically involves both automated and manual methods to really push the models and see where their weaknesses might be.
Okay.
And a really interesting thing they're doing is called generative offensive agent testing, or JO8,
Okay.
which is basically, it uses automated simulations of potential attackers
Mm.
to try and find vulnerabilities more efficiently. So their human security experts can really focus on the more complex and novel threats.
Yeah.
So it's a more proactive and scalable way to kind of find potential problems before they arise.
Okay. So finally, the blog post touches on the ecosystem and the future of Llama.
hmm
So what are some of the main points there?
So a big thing they emphasize is that making these models openly available is really crucial for fostering innovation.
Mm-hmm.
So by releasing Llama 4 Scout and Maverick on these platforms like llama.com and Hugging Face,
Yeah.
they're really empowering a huge community of developers and researchers to build new things, exciting things with these models.
Yeah.
They also believe that truly intelligent systems need to be capable of doing lots of different things.
Yeah.
Having natural conversations, solving problems they haven't seen before,
Yeah.
really being able to generalize. And it's not just about the AI models themselves, right? It's about the broader technology infrastructure
Right.
and how they're integrating these models into their own products. So they're really focusing on the whole tech stack,
Yeah.
including integrating the Llama 4 into products like Meta AI and WhatsApp, Messenger, Instagram Direct,
Right.
and the Meta.ai website. They're also continuing to work with partners across the AI community, and they're looking forward to sharing more of their vision at their upcoming LlamaCon event.
So it really feels like Llama 4 is a big jump forward in the world of these openly available AI models. So to kind of bring it all together,
Yeah.
what are some of the key advancements that you think we should really take away from today?
I think there are several really big ones. So first, significantly improved ability to understand and process both text and visual information together.
Mm.
Second, a dramatically increased capacity to handle very long sequences of information,
Yeah.
particularly with Llama 4 Scout and its 10 million token window. Third, substantial gains in overall performance
Yeah.
across a whole variety of benchmarks. And finally, a really strong commitment to safety, including the release of those open source tools we talked about,
Mm.
and ongoing efforts to ensure that these models are used responsibly.
And ultimately, I think, the goal is to really empower people to create more innovative and personalized experiences with AI.
I think so, yeah.
Mm.
And by making these very powerful models openly accessible, they're really hoping to spark a wave of creativity and problem solving
Yeah.
across lots of different fields.
So to kind of wrap things up, here's something I want everyone to think about.
Okay.
Consider how that 10 million token context window of Llama 4 Scout might fundamentally change how AI can process and understand huge amounts of information. Think about areas like scientific research, in-depth legal analysis, or even managing and understanding our own personal knowledge.
Yeah, that's a good point.
What new possibilities does that unlock? Things we haven't even begun to think about yet.
Right.
So we really encourage you to explore these models.
Yeah.
Continue learning about this fast-moving world of AI.
It's changing every day.
It really is. It really is. All right, well, that's it for today. Thanks for joining us.
Thanks for having me.
We'll see you next time.